Hello everyone. Today we will be starting with our machine learning knowledge gaining sessions. So for that, first of all, we will be knowing a little bit of terminologies of machine learning, and then we will go into the practicality of it, the practical knowledge of it. So for that, we have to first know few of the details like a little bit of statistics and all. Many people are there who are very worried about mathematics behind machine learning and all, but while you are doing a work in a practical organization and all, right, then if you are doing in say Python, then all the libraries are there. You don't have to mathematically go and do something unless and until of course you are going into deep learning and all, where there are some complex mathematics behind it, and also unless and until you are going into something of a boosting and all backing, which are into a much complex thing. Of course nowadays you have to go into boosting and backing and all the gradient descent, but that mathematics also we will be seeing in the sessions, that what is the maths behind it, and how we can know it in a simple term. So there is nothing of a very high funda mathematics, but they are simple ones, and we will see that and we will know those. Now for that, first we will know the inferential statistics. Inferential statistics, something like a few days back there was the elections in the United States, right? So what happened is there were some polls and all. So before that, people tried to predict that who will win, whether Joe Biden will win or Donald Trump will win. So that point of time, they did not go to everyone and try to predict, right? Because then they have to go to millions of people. So what they did is they went to a few people whom they have selected, and they told, okay, from this we can predict that what will be the outcome of the elections. So those people whom they have selected, right, say 1,000 people, 10,000 people out of the million, they are called the sample data. They are the sample data, that is denoted by small n. And the whole, say the whole number of people in USA is called population. Not that population, but anywhere, say the total data which is there, that is always called population. In that, what is being taken out is called a sample. Now we will try to understand other probability details from example. So for that, we will go through a casino example, and we will get to know few of the probability terms. There are many terms, and we will go through few of them today and rest of them the other day. Okay, so for that, our casino example is, we have got 5 balls. Okay, 3 of them are red and 2 of them are blue. Now it goes like, you pick up one ball, and then you put it back again, see the color of the ball and put it back. So if you get 4 times red ball, then you will be paid $100. And if you say for each of that time, right, you are paying, then for each of the time you are playing, you will have to pay the casino guy $10. Okay, so $10 you are paying for each time playing, and if you get 4 times red ball, then you will get $100. Now we will see in this example that how they decide whether it will be a profit or it will be a loss for them. So they already know that even if you win, right, what they will gain and how much they will gain. Now let's see that. Okay, so first of all, we will see a method which is a little crude, and then we will see a scientific way of doing it. So for that, we take this. See, if somebody is trying to take the red balls, right, then there can be this many situations. It can be all blue, 1 blue and 3 red, the 2 in this way, like while he picks first time, second time, third time, fourth time. So it can be red, 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 then blue he gets. Of course he is very unlucky. Fourth time if you would have got, then done. So it can be in this many ways. Likewise, he can get 2 blue, then 2 red. He can get blue, red, blue, or red, blue, blue. So this many conditions. Likewise, others also. So once he picks up right, then if we go and we check with the data, we see that he has done 75 times he has picked the balls, or somebody has played, and in that the data typically comes in this way, that 2 times with 0, 1, 2, 3, 4. So while he picks right 0, as in we are plotting here number of red balls, so he picked up not the red ball, then 1 time is this, 2 times this, 3 times this, and the number of times red ball is being picked is on the y-axis. Okay, so the probability of picking those balls right, for that we have to know a term called random variable. Random variable is denoted by x. X is here the number of red balls. It can be different also. It can be the amount also, which is getting like $100 and $10. So based on what I am trying to find out the probability, that is the random variable. So here px right is equal to 2, that is this one is 26 by 75. 75 is the number of occurrences. Means the sum of all this 10 plus 25, this is 25, this is 26, 12 plus 2, this will be 75. The total number of times he has picked up, right? It will fall in any of these buckets, right? So likewise px3, that is this one is 25 by 75. So that these all data we plot, but this data what we have plotted is using a crude way, okay, not using any scientific method. Now once we plot this right, the plotting of the x to the px, that is called probability distribution. Probability distribution is helpful in many ways. We'll see that in the future lectures as well. Now what we are seeing is another thing, which is the importance of this px. The px is 160.160. What does it mean? It means that 1000 plays happen, then 160 times it will be 1. So if you sum all this right in 2000, sum all this, it will become 1000. So for that, another concept we have to know, something called expected values. Now what is expected values? Expected values is the sum of the occurrences, right? So here the total red ball occurrences will be actually, as per the probability formula, 0 into 0.27, 1 into this whole sum. So that sum right will come to 2.385 actually, okay, or you can just multiply it with 160 and all, which is for 1000, and then divided by 1000, it will be 7. It will become 2.385. So this 2.385 means that if I play an infinite number of times, right, probability of it is coming is of a ball picking is 2.385. Although that might not make a direct sense, because you cannot pick a ball 2.385 times, either 2 times or 3 times. That means it falls somewhere in between. It's just a probabilistic term, okay? But you need to know the term, because we'll see what's the utility of it. Next we change the random variable, which we were previously making the random variable as number of red balls, right, in our previous thing. Now we are making it as $100 and -10 as in from the casino perspective, right? It is a -10, so he's getting the money actually. So that way. So now if we come to this thing, he's getting here, he's got px $100. So now see, in the previous one, what we got the number of red balls was 0.113, right? This one point, this condition, while he is getting the 4 red balls, this is number of balls he can get. So he can get 0, 1, 2, 3, 4 times. If he is getting red ball, the chances are this many, 0.13. But at the same time, that we can interpret in a different way. He gets the $100 also, right, that point of time. So then it becomes Px is equal to $100 and is equal to P of red ball. These two conditions are same, right? So we have changed the random variable just from one thing to another, and so for that also it is 0.13. So now for the person who is playing, to get give the money, right? Each time he is playing, he is giving. So that probability is the sum of all the times when he is not getting the 4 red balls, right? That can be 4, that can be 3 red balls. That is not 4 red balls actually. This is a wrong thing. It can be 3 red ball, 1 blue ball, 1 blue ball, 3 red ball, 2 red ball, 2 blue ball, and also 4 blue balls. 4 blue balls, right? That means in our condition, this 0.867, he is summing up which ones? These all ones, okay? So these all, if you are summing, then it comes to 0.867. That is the probability that he will not get 4 red balls. We have already found out the other condition, right? That when you get the 4 red balls. Now for that we can say P is equal to $- minus 10, right? Because that point of time he has to give $10. He is not winning, that means, okay? Now we will see from the expected value which we saw in the last example, right? We will see that what is the use of it. So again we find the expected value. Expected value is this 100 into 0.133 plus this minus 10 plus this. So that means 4.63. So that means till he does this, right, he is actually in positive meaning that the casino is losing the money. So how he can make it better is he can take $20 from the guy for each time he is playing. Then it becomes 16 point something, right, this multiplication, and then that point of time it will become minus 3 point something. So he is gaining something. Minus means the casino guy is gaining, okay? So now we come to a more scientific way. There we had gathered the data using practically we are going, somebody is playing and getting the data, but we can do other way also, which is a scientific way of doing it. And in that place what we will do is we will do a binomial distribution. So binomial distribution, how we will do here is we will first find out P of one red ball in one trial. That means trial here means number of times he is picking up that ball. So the chances of a person getting one red ball on the first one time he picks is 3/5. That is number of total balls, okay, the red balls divided by number of total balls. So that is 3/5, that is 0.6. Likewise for blue balls, if he is picking, so the chances are 2/5. Two blue balls divided by number of balls, it is 2.4. So the sum is again becoming 1. Always it will be 1. So we have to know another thing here, that the probability of an event, if there is an AND condition, right, event 1 and event 2 can be in a multiplication form. So this is equal to this. So how that is helpful, let's see. So probability of 2 red balls in 2 times, that is 2 times he picks up and 2 red balls he gets. That probability is P of red ball in trial 1 into P of red ball in trial 2, that first time red ball into second time red ball. That means 0.6 into 0.6. Each time it is 0.6, right, red ball, so it is 0.36. So probability of 1 blue ball and 3 red ball is 0.4. That is one time the guy picks up. Yeah, so he picks up red. He picks up this thing, the red ball, blue ball, like that. So that chances are 0.4 into 0.6 into 0.6 into 0.6 into 0.6. This is one time chance, one event, like once he picks up. So what I mean by that is this 0.4 into 0.4 into 0.6 is this probability. 1 second. This probability, that is this one time. So like that there will be 4 of them, right? So 4 of them means 4 into that probability, right? This one into 4. Okay, so that's why we are doing here a multiplication of 4, because he is picking 4 times, but rather I would say not picking 4 times, but 4 ways it can become 3 right? So that is why we are making it into 4 into that probability. Okay, so now we get this, for this is for one time into 4. Okay, now likewise we can find out other p of x of 0, that is all blue balls, one red ball, 2 red ball and 4 red ball. This is our condition of all red balls. So the probability is 0.1296. Okay, this is the probability for all red balls. So now we will know few terms of other terms like probability density function and cumulative density. So before we know that, right, we have to know that a variable, or a variable as in, like these are the variables, right? This anything, commute time, probability, or whatever, these details are variables. Each variable we can call, right? So these variables can be, or a value, anything can be in two ways. It can be discrete, it can be continuous. Like you are wearing a smartphone, right? You are having a smartphone, so that smartphone takes your BP, and each millisecond, each second it takes the BP. So it's a continuous data. You will have data at each point of time. So that is a continuous data. Discrete data, as in we were picking up the balls, right, last time. So the ball will be one only, right? It cannot be 1.22 balls or 5.56 balls, right? It has to be a whole number, right? So that kind of thing. So from that point you will know one thing. Here we have got an example wherein we are getting the details of students coming to school and how much time they take to commute. So 20 to 25 minutes they take 0.15 is the probability, 25 to 30 is 0.20. Now till now we have seen the probability density function, that is the probability of each instance, right, each occurrences. Now we will know something called cumulative density function. That is see here 0.15 was the first, then 0.2 got added because it got cumulated like that. So it will go, it is like a rolling sum. So what will happen is, if you plot this, right, it will have kind of an increasing graph, rather than in other places, right, we can have a increase and a decrease. We will have here a full increase of a graph because it is additive, right? So this is called cumulative density function. Okay, sum of each probability it is. Now we will come to know something called normal distribution. Generally in nature and all, right, everything is in normal distribution form. Normal distribution means when we are plotting the data, right, the most of the data will fall in the middle and the others will be a little less. So for that we will know two things. First is mu and sigma. Mu is the mean of a value. The mean is average, okay, and standard deviation is the deviation from the mean. Say the mean is 100, right? Say average, somebody is going in a car and the car speed is 80 kilometers per hour or 80 miles per hour. So that is the mean, right? Now from that mean, it does not mean that he has been driving all along at a constant speed of 80 miles per hour. No, he has been going up at 100 and sometimes he has come down to 50. So that is the mean, that is the average. Standard deviation means at each point of time, suppose he was driving at 70 kilometers. So from the mean, which is 80, he was below, he was minus 10, right? So that is standard deviation. Now, so in a normal distribution, they define it based on two things. One is mean, one is standard deviation. So mean being the mid, so they define how much the standard deviation is from the mean value, right? So as you can see, right, it is mean plus 1 standard deviation, or mean plus 2 standard deviation, or mean plus 3. So generally what happens, the data, measure of the data, right, like 68.27% rise between mean plus 1 standard deviation, and 95.45 within 2, and rest of them like 99.73% lies within mean plus 3 standard deviations. Okay, this is the general normal distributions characteristics, we can say, right? So now we come to an example wherein we see that when we are going with a, say, mean of 35, right, and a sigma of 5, and we want to find out of the probability that he was within 25 and 45. Say he was driving, our mean of a driver is 25 miles per hour and his standard deviation is 5. Of course he is driving a bit slow. So we find out that what is the probability that he was driving between 45 to 25. He would have gone high and low, right? So that probability is that sigma minus mu minus 2 sigma and mu plus 2 sigma, because mu 35 minus 2 into 5, that is 25, and likewise 35 plus 2 into 5 is 45. So that means within this means this to this, right, which is 95.45, this one. So chances are this. In this perspective, we have to know another term which is called Z score. Z score is for generally for standardization and all, which we will see later, but we will just know the concept of Z score today and we will know other things later. So for that, mu is say 35, sigma is say 5, like previous, and we want to find the Z score while x is 43.5. This probability we want to find out. Probability that the person, for probability that x was less than equal to 43.5. Now how we can find out that thing, right? We can find out that by doing this formula, like the x minus mu by sigma. So we get the value 1.7, right? Because 43.5 minus 35 by 5, 1.7. Now from that we have to go to our Z score table and find out what is the probability of this. So while we go to it, right, we have to go to the Z score table which is there in the net. There is a negative value, there is a positive value, ours is a positive value. We will go here and the value for us will be, we have to get the intersection of these. This means that 1.7.01, say, then it will be this one. Okay, see, 0.01, that means 1.7.01, 1.701 for that. So but for us, right, we have 1.7 only, we don't have any other decimals. So for us the value will be 0.9554. by mistake it's written here a little different, 9554. So that will be, so that means, what does that mean? That means that the probability that the person was traveling at a speed of 93.5 is 0.9554, that is 95.54%, you can say. because had he traveled much more right, his average would have been higher. It's quite common, right? So that is the Z score. But where Z score is used and all, that we will see in our practical things later on. But for today we will just know this is the Z score. So today we learned these concepts like the Z score, normal distribution, probability density function, and cumulative density functions, as well as we have also known a little bit of how scientifically we can find with a binomial distribution, and also a little bit of random variables and probability distribution functions. All these concepts we come to know, and we also seen inferential statistics one example. In the future, what we are planning is we'll see some practical examples, like applying algorithms to some practical examples. Okay, so that one we will see, but for today we will be stopping here. And in case if you have any questions or queries, right, feel free to write in the comments. I'll answer that. And of course there are many concepts, so planning to cover it in 3 or 4 days span, and then probably we'll go into the coding part of it. But before coding we have to know few things, like we have to know the pandas, we have to know numpy to a basic level, otherwise things will become a little complex and again we have to backtrack. So that's the goal. In case if you have some suggestions or anything, you can let me know. I will post this one, this PDF in the GitHub repository, and let's see how it goes in the future. Machine learning we will go, but parallelly we will also go through some other Spark and all, like we have been going till now, right? And that's what the plan for the future is. We'll go through next some more theory. Okay, the theories are a little, to some people it might seem a little boring, but please understand this, because later on while we go to the practicals it will be very helpful, and we can correlate this to our practical knowledge which we have gained here. So you also do your little understanding. You can of course go and do little bit of Google, and there are a lot many materials in the net, but whatever I have covered here, I will be covering the practicals based on this only, so that they are related. I won't go into some concept which has not been covered theoretically. I will look into that. So that's for today. Thank you, and bye bye.